Welcome to this eLearn security training video lesson on Metasploit framework. In this video, we will see what Metasploit is and how we can use it in order to perform basic operations. We will inspect its basic options, arguments, and syntax. Before diving into Metasploit options, it's important to make sure we are using the latest software version. We can verify if there are updates available by using the MSF update module. So let's open a terminal window and run the MSF update command. Once we run the command, the update process starts, and as we can see, there are no updates available. We highly suggest you keep your Metasploit version up to date in order to have the latest modules and exploit available on your machine. Now that we know we're running the latest version, let's start the Metasploit console. Metasploit offers different interfaces, but for this video, we will use MSF console. This is the most popular and efficient interface. Before running it, it's important to know that Metasploit uses Postgres database for better performance, and thus, we have to configure our machine accordingly. We can start the database service with the service Postgres SQL start command. Keep in mind to execute this command under root privileges. Now, we're able to run MSF console. To do this, we call the MSF console command from the terminal. As we can see, we have successfully executed Metasploit. From here, we will execute our commands, configure modules, trigger exploits, and more. To get a taste of Metasploit options, we can run the help command. As we can see, a big list of options and commands are displayed. We'll examine some of them later in this video. One of the most fundamental commands in Metasploit is search, and it's mainly used to search among Metasploit modules. For example, if we have a general idea, like an exploit for a Windows system, we can use the search command to narrow down the results for a specific exploit. Moreover, we can search among different pieces of information such as exploits written by a specific author, exploits that affect a specific platform, exploits that have a specific CVE, and more. Let's see some examples. Let us suppose we want to find all the exploits that affect Windows systems. We can do this by running search with two parameters, type and platform. Since we want to list all Windows exploits, we'll have to set type to exploit and platform to Windows. As we can see, we get all the modules related to our search values. As we said earlier, we can also search for all exploits that have been created by a specific author. We can do this by running the search command with the author parameter. In this case, we are looking for exploits written by HDM. As we can see, Metasploit prints out the list of modules that have been created by the author specified in the search command. Moreover, with the CVE argument, we can look for exploits that have a specific CVE number. Let's look for exploits whose CVE contains 2015. As we can see, all the exploits that contain the number 2015 in their CVE are listed in the output. The search command is very powerful, and it helps us to list the module according to our needs. It will save us a lot of time from looking among all the modules that Metasploit offers. If we know the exploit we need to use, we don't have to remember its path. We can find it with the search command. Another common command used with Metasploit is the show command, which we can use to list all the available modules that Metasploit offers. If we write show and press tab 2 times, we can see that we can use the command to list all the different modules by their category. For example, we can see there are different categories such as exploits, auxiliaries, payloads, and so on. Let's try to list all the modules in the exploit category by adding exploit to our command. From its execution, we can see the enormous list of exploits that Metasploit serves. Here, we can find exploits that work for different operating systems, services, architectures, and more. In the results, we can also see the date of the exploit, so we can rely on this information to use the most updated exploit. To understand the upcoming steps, it's important to know what Metasploit payload is. The payload is the actual piece of code which can actually do something on the remote system, the one we're trying to exploit. While an exploit abuses a vulnerability, in order to do something on the machine, it needs a payload. As you can imagine, payloads are useless without the exploits. They wouldn't have a way into the system without them, but exploits would be useless too without the payloads. They would have a way into a system, but they wouldn't do anything else as soon as they run. Let's see what payloads Metasploit offers. To list all the available payloads, let's use the show payloads command. As we can see, Metasploit offers many different payloads, each one with its purpose and scope. They're well organized in order to let us understand the type of payload we're using. The first part of the payload name indicates the target operating system. Here, for example, we can see that these payloads will work on Windows OS. But if we scroll up in the terminal, we can see that there are payloads that target Linux, Java platforms, and so on. The second part of the payload right after the slash usually indicates the platform version. This may be x86 for 32-bit OS versions or x64 for 64-bit OS versions. After this, we will find the actual type of payload. Here we can choose a simple shell, a meterpreter shell, PowerShell, and much more. This indicates what session we will obtain once the exploit succeeds. The last part indicates the type of connection that we will create with the target machine. Reverse means that the payload, once executed on the remote machine, tries to connect back to our machine. Bind indicates that the payload binds itself on the remote machine, so we will have to start the connection to the exploited machine. Don't worry if you find this information a bit confusing at this time. They'll be clearer once you start using Metasploit. Besides the payload type, it's important to note that every exploit supports different payloads. Thus, a payload that we can use with a specific module may be incompatible with a different one. On the next example, we will use the meterpreter payload, which is the most common and powerful payload we can use in Metasploit. As we previously said, we can use a reverse or a bind payload. Once again, the main difference between them is that a bind payload binds itself on a specific port on the victim and then listens for incoming connections. The attacker then connects to that port and establishes the connection. The reverse shell is mostly used when the victim is blocking incoming connection or the machine is behind NAT. Here's the victim that starts the connection to the attacker. Before actually using an exploit or a payload, let's see how we can retrieve information about a specific module. To do this, we can run the info command, followed by the module path. In this example, we want to get more information about the exploit located at the following path. In the results, we can see information such as the name of the exploit, its license, the targets it's aiming to exploit, the disclosure rate, the author, a small description of the exploit, its options, and much more. We suggest you use the info command when dealing with new exploits. This command returns information that may help you to better understand the exploit's usage and its target. Let's see now how we can use exploits and payloads in real scenarios. The module we will use as an example is the following. It is an exploit that targets Windows systems and more specifically the SMB service. As you can see, in order to use an exploit, we have to type use followed by the module path. Note that while typing the exploit path, you can use tab in order to auto-complete the folder's name. This may save you some time. Once again, the module path here reveals a bit of information. The first directory in the module path is the category, in this case exploit. The second folder we specify in the path is referred to the platform we would like to exploit. The next folder indicates the vulnerable service or protocol used, and the final part of the path is the actual exploit file name. Once we execute the command, we can see the name of the exploit highlighted in red. This means that we are currently using the module. To understand better how Metasploit uses the modules, it's important to understand that these modules are installed to our system, so we can browse them in the Metasploit folder. Let's open a terminal tab and browse the following path. Here's a folder where all the exploit modules are located. With the list command, we can see different subcategories. For instance, let's inspect the Windows and list its files. Here again, we have a few other subfolders that contain different exploits for different protocols and applications. Let's then select SMB. If we list the exploits, we will see all the available exploits that exist against this specific service, and we can see the module selected in Metasploit. Back to MSF console, we are ready to configure the exploit. Keep in mind that not all the modules have the same settings. For instance, an exploit targeting a browser might have different port listening specifications than the one we're using now. Another important note here is that once we use a module, we can run the info command to get information about the selected module. As we can see, we have all the module information printed on our terminal. Now that we have a good understanding of the module, we have to configure it. We can print all the module options by running the show options command. On the current exploit, there are 3 required options. Let's see what they are and how to set them. The first one is called remote host, and we will use it to specify the target IP address. The second is the remote port. In this case, the option is already set with the default value, so we will leave it as is. The third option is SMB pipe. This is an option we will not see in all the exploits since it is specific for this one. As you already know, different modules might have different payloads. In order to see all the available payloads for this module, we can run the show payloads command. Notice that since we're within a specific module, Metasploit lists only the payloads available for the specific exploit. Here indeed, since the exploit targets Windows machines, Metasploit will not list Linux and other payloads that will not work on the remote system. Metasploit also allows us to view the target system that the current exploit affects. To view this list, we can use the Show Targets command. As we can see, a list of 72 potential vulnerable operating systems is prompted. For this example, we will use the option 0, which tells Metasploit to automatically choose the target system. Now that we know which options we have to configure, let's start setting them. We can do this with the set command. The syntax to use is very simple. We just have to write set, followed by the option we want to configure, and then the value to assign. Thus, if we want to assign an IP address to the remote host option, we have to typeset our host, followed by the IP address of our target. Now, if we run the show options command once again, we can see that the value has been successfully parsed. Indeed, our host now has the IP specified by our command. Let's now suppose we don't want to use an option anymore. We can unset it by running the unset command, followed by the variable we would like to clear. As those options are required for the exploit to run, we will set them back again. Let's now set a payload to see some extra options available. We'll use an interpreter payload. To do this, we run set payload followed by the payload path. For this example, our payload is located under Windows/interpreter/reverse_TCP. Now that we have set the payload, let's see again the available options. As we can see, more options are available. The second part is related to the payload we have set. The option lhost stands for local hosts, and it is used to identify our local machine. This will be the address that the payload will use for the connect back. The L port stands for local port. This will be the port that our machine will be listening for connections. The default value is 4444. The exit func option sets the DLL, and the function that the payload will call once it is complete. For now, let's leave it at its default value. As our machine is fully configured, we're now able to initiate it against the target machine. We can do this with the exploit command. As we can see, we've successfully exploited the system and an interpreter session has been opened. We currently have full access on the vulnerable system. On the next Metasploit video, we'll see how we can use Meterpreter and what we can do once we compromise a system. Thanks for joining us.